Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna do just like a trivial explorations of one new node in Sverchok. It's another some type of vector functions. It's a vector turbulence. It's a turbulence noise. Sometimes you know it. I think you probably have used this at some point if you are using one of Blender modifier. I believe Wave. The Wave modifier is kind of using turbulence. I don't know if Blender Particles also using this turbulence node, but yeah. So there is already vector noise quite a while, and then there's also vector fractal. Yeah, they are all kind of I think kind of overlapping each other. They're slightly different, but they are definitely very interesting nodes to play with, especially if you just want to play around, and you can start with these nodes. That they are pretty easy to use, and they are kind of interesting. You can plug in. Let's see. Let me save this first. You can plug in anything into this guy, any generators or any 3D objects that's like a polygon mesh. But for the basic use, you can try plugging in line or plugging in plane. And I have a few ways that I always use. Let's start with line first, okay? With vector noise, you already know. I did this many times, but I'll do it again. So line will generate line that grows in x-axis. That's always like a kind of like the story that I always tell to anyone that's used Sverchok for the first time. Line will generate lines in x-axis. Okay, it's just going that way, and it's growing the x value is kind of growing. If you look at it using the stethoscope, you will see the x, this is x, y, z, and the x kind of growing. Okay, that's very basic, very simple idea. And you plug this into vector noise, and you will get this. Suddenly the line gets a bit crazy. But if you reduce the step, and you will see that the line's kind of it's not being pushed, but every point's kind of traveling through the noise. Now you can do it that way, or you can also use vector math. Vector math here, and you simply plug in the original points and add the noise on top of this guy, and then plug this guy in, and you get a different result. Now you will see that in this case the line is still growing in the x-axis, but there is some kind of noise that's kind of traveling through. So this is the second way you can play around with vector noise. Now let's try vector fractal. Vector fractal actually will output only scalar value. Vector noise actually have that option as well, scalar. With scalar, of course, you cannot just plug in scalar into vector like this. It's not gonna work. You need to kind of tell it you want this scalar value to go to the x or the y or the z. For example, the z, and you plug these two together, so you get the noise kind of pushing it in one axis. So that's how one way you can use scalar, but you can do it in many different ways. So vector fractal can do that. Very similar, but it's also slightly different. From one side, it looks like kind of like a mountain. Okay, so that's vector fractal. This is vector noise. You can change the noise, and you get a different result. This is my favorite cell noise. Now you have vector turbulence. Vector turbulence also kind of doing it, and you see this guy also have scalar and a vector output. Very interesting. Remember this. With vector, you will get some things kind of like it's being pushed in every point is being pushed in XYZ directions. Okay, and you can increase the amplitude and play around with the frequency. Sometimes less is actually more interesting. You can also, if you really want, you can kind of push it. So instead of having random seed, generate random numbers each time. But if you use vector, something like vector move, if you use move node, you will see here that you can kind of push it in the x-axis. That's this way you will see that it's kind of, this guy is now kind of traveling through. It's like the noise is being pushed, but it's actually the opposite. It's the line that's kind of moving. You can do it in the y-axis, on the z-axis. From the motion alone, this looks like a little bit like thunder or lightning. It's lightning, I think. It's simulating like a natural phenomenon. That's a thing. So you can use the move. You can play around with that idea. Like I said, you can also use just the scalar value and plug this into the z, and then let it calculate, and you get this only one axis kind of a vector turbulence kind of influencing the line in the z-axis. So that's kind of nice. So we can delete vector fractal and vector noise. Let's focus on vector turbulence. A single line is interesting. You can have multiple lines, and multiple lines also you can have different seed. That's the thing about Sverchok that's I really like, you know. So you can have like multiple of this guy. For example, you use vector, or let's say use range float and vector in, and let's put the range float in the y-axis. You'll get this. You can have as many or as little as you want. You notice that each of the line has the same turbulence passing through. If you want a different one, you can use range float integer and plug this into the random seed. And for this guy, I believe you can have a different noise, unless I'm wrong. Unless I'm wrong there, and this vector turbulence might not. This guy might not have the vectorization happening yet. Maybe I'm wrong. So I don't know yet. So this is let's say I have 10, and this one is 10 as well. And if I change the seed, okay, that's changing. Okay, I think the vector turbulence might not have the vectorization yet, because if I use vector noise, plug in the vertices there, and then this guy in there, this guy goes into this guy, we get a different result. So yeah, unfortunately, this node might not be vectorized yet, but I think you can get around that. Anyway, instead of using line, and instead of using the matrices and confuse us, let's just use a plane, for example. Plug in the plane and plug in the turbulence. And this is the source point of the plane. And we get that points. Plug in the polygons, and we have this. Let's reduce the amplitude of the turbulence, but increase this to 20 by 20. We have 400. You can go crazy with this number on your own machine, but I'll do it just like this. So you can see this guy is kind of doing like a wave. If we use vector move node, plug into this guy, and this vector in, plug into this guy, and we move it, we have something that looks like a ocean wave, and it's doing it in all three directions in X, Y, Z. And so that's what vector turbulence kind of doing. Just like the kind of like the ocean wave, you can play around with the frequency, you can use the different seed, you can use different octave, and you can also use different functions. So yeah, so that's in at the very basic, that's what this guy is doing. It's probably just a slight variations of vector noise, but this guy have frequency. I think that's the difference, and also have amplitude control over the amplitude. It's kind of pushing it in one direction though, but also have an octave, and you can control the hardness or the softness of this. Sometimes really it's not quite easy to visualize, but if you use things like texture viewer actually you can use texture viewer in a RGB, like a color mode, but currently I keep getting this just grayscale. So let's try 64 by 64 and plug this into, I think we can use the scalar mode, plug into this guy, and we can sort of see the texture as well. Okay, that's the result. Probably we can go a little bit higher. I believe we can use mapping for this guy. So 1 to 64 become 1, become 0, and 256. Oh, I think I'm not doing this properly. Yeah, I think I'm not doing this exactly properly. Back to 64 by 64, but that's what the turbulence looks like anyway in that small picture. We can go 128. It's going to be a little bit slower. There's another way to do this and make it more interactive, but for now that's probably enough. It looks kind of like an ocean, right, from the top. So this is, if you kind of imagining it in a kind of like a grayscale texture, this is what it looks like. If it's a RGB, maybe it looks a little bit better. It looks more like an ocean with all different normal XYZ directions. But yeah, you can just give it a try. I guess you already know you can use line or plane, or you can use any others, and try to see the result of this vector turbulence and how it influences any of this 3D objects generator. Try it with Suzanne, bring it into Sverchok, and try this vector turbulence. It's almost like the modifier. In fact, I think at this stage, Sverchok nearly version 1.0, it's almost simulating any of Blender modifier. It can simulate any of this kind of, more or less. It's doing all this for modeling purpose. Sverchok also can do some of it. I think what's kind of holding Sverchok development is Blender's capability of nerds and dealing with curve. That's kind of I think Blender needs to step up in terms of curve modeling. Like curve is very parametric, but polygon and mesh is a little bit different. But anyway, I think yeah, even at this stage, Sverchok is really powerful for procedural kind of workflow. So you have like nearly 200 nodes, I think, and on top of that, you have also script nodes. Where is it? Scripted nodes. You can easily quickly prototype it using Python script. So anyway, that's a lot of power, a lot of talks. But basically, Vector Turbulence is a new node in Sverchok, and this is again adding to on top of other recipe that Sverchok already have. So give it a try. Let me know what you can come up with. Thanks again for tuning in. Hopefully this video is useful. Any question, feedbacks, let me know in the comment section below. And I'll